Hello everyone, this is Raza, or you can call me Zafra, and we are back with another LeetCode problem, which is 167 to sum 2. And in this problem, input array is already sorted. If it was not sorted, then the first step would be that you sort it out. But we are not going to go through the reason for that, and we are going to solve this problem in two ways. First, so we are going to look at it as like a brute force way first, and then we can solve it in a more optimized manner. So you might remember that this problem is pretty similar to the one that we solved before on this channel, and I'll add a link to it above so you can actually check that out. So it is actually recommended that you check that out because it's like a precursor to this problem. And in that problem, we actually solved that problem using a time complexity of O of n and space complexity of O of n as well. What's different about this problem that we are actually required to use constant extra space, so we cannot actually do a O of n space in this problem. And let's just go through the problem once. So we are given a one indexed array of integers that is already sorted in non-decreasing order. Find two numbers such that they add up to a specific target number, and let these two numbers be like numbers index 1 and numbers index 2, where 1 is less than equal to index 1 and index 1 is less than equal to index 2 and index 2 is less than equals to numbers of length. And we have to return the indices of two numbers. So we have to return the index 1 and index 2 of two numbers that when added together, they make a sum of target. Alright, so how will we do this in a brute force manner? So let me just write down brute force here so we don't confuse it. So we will use two for loops, and we will go through this item elements once in the above for loop. So we'll go through 1, 2, 3, 4 and 9, and in the second for loop we'll go through, let's assume this is I. Okay, so this is I, and in the second for loop we'll go through whatever the I plus 1 is. So in this case, if we have picked 1 first, we'll go through 1 here and plus 2, then 1 plus 3, then 1 plus 4 and 1 plus 9, and the second time we'll go through 2 plus 3, 2 plus 4, 2 plus 9, and the third time you will be going through 3 plus 4, 3 plus 9, and at this point we'll actually get the answer 12, which will be the answer, and we can actually return it. But you can imagine how weird it would be to do it in two for loops, because this is not the optimized way, and this will give us a time complexity of n square. It would give us the space complexity similar to the one asked here, but we will not get the best optimal time complexity. So what we'll have to do is do it in another method using pointers. So let me just clear this up here. Two pointers first. So this is a pointer 1. Let's name it pointer A, and this is a pointer B. Now the good thing is this array is already sorted, so that is a really crucial part for this solution to work. So pointers will not work if this array is not sorted in increasing order. So if your solution, if the problem you are given in an interview is not sorted and you think the problem is pretty much like two sum and you need to solve it in a really optimized way, so you have to sort it first. The complexity of the program will change a bit, but that's a necessary step there. Right now we don't have to sort it, so let's just go ahead with the solution. So let me make a representation of it. Now we have pointer A and pointer B, and we are actually going to use our pointer A and pointer B at these locations. So this is pointer A and this is pointer B. All right, now we will match the value at pointer A with the value at pointer B. Okay, so if we have taken the value of pointer A and value of pointer B at this time, so let's assume we are at iteration 1 of our loop, and we take 1 and value of B, which is 9. This gives us value of 10. We will compare this value of 10 with our target, and this is not equal to our value of 10. But the thing that we have to note here is this value of 10 actually less than or greater than our target sum. So if it is less than our target sum, then we know that we need to increment a, because if we increment a, we are bound to get another larger value at this position. So if we increment by a, we will get 2 here, and we can keep the b position at the same place, and we'll get 2 here, and this will make it 9 plus 2 will 11, right? So you can tell why did we have to actually increment this, because we were actually required to increase the value since we got a value that was smaller than our target. So at this time, we are at here actually, and this one is still at this position. All right, now we have to go through the loop again, and at this iteration we will move our a again towards 3, because our 11 number is actually less than the target number, which is 12. So let's move it. This would make it 10, 11 and 12. And when we have actually found our result, because this number is actually same as our target, then we can return the index of this pointer, the a pointer, and we can also return the b point. So this would be our actually answer. Okay, and in this problem here, they've actually do a +1 here, which will give us our answer. Okay, so this is just a requirement. They wanted us to return indexes which are greater than 1, so it's like just increment it once and you'll get the correct answer. Okay, so we have another problem here. This is my custom-made problem to better give you the idea of the solution. So let's say that this is the input array that we got. It is ordered by increasing order, so 4, 6, 9, 11, 12, 15, and we are given a target sum of 20. Now we are going to use the two-sum problem with the same solution of pointers, and we are going to start from this position, which is pointer A, and this position, which is pointer B, whereas we'll start our loop and we'll go through this array one item at a time. And let's say that we went through this array for the first time, and we are at pointer A and pointer B. We are going to plus these two items, and we'll see if we actually get our target. So we plus 4 plus 15, we get 19, which is not 20, but we can see that we actually have to increment because we are less than our target here. 19 is smaller than our target, so we have to increment a bit to another index here, right? So we're going to increment this, and we'll do this by just removing it, and let's have our pointer at this position now. And now we have pointer at B and pointer at A. Now let's just increment, let's just sum it up again. So we sum up 6 and 15. 6 and 15 plus together, summed together, would give us 21. Okay, so you can pretty much tell that we actually have overshot our sum. We are above our target now, so we have to, I think, you know what, I'm going to add a sort of a plus here. So we have to increment here, and in this one we have to decrement, because this is greater than our target. We have to decrement something, and when we have to decrement something, we move our pointer B, and when we have to increment something, we move our pointer A. So let's move our pointer B backward. So we'll have our pointer at this position now, and we'll check it again. So let's see again. 6 plus 12 is equals to 18. As we are below our target again, we have to increment again. So we'll do a plus, which is A, and we are going to move this A to 9. This will remain the same, and let's see our next iteration, which will be 9 plus 12, and this will be 21, I guess. So you can pretty much tell that 21 is still above our target sum, so this is not the answer. And you can also see that we actually have to decrement again. Let's decrement, and this B would be moved backwards now, and it would be at this position. Let's run the calculations again. This will be 9 plus 11, and voila, we have our 20. And when it's actually equals here, we can just return this. So let's just say that we have an answer here. We could say that the result is actually 9 and 11, and we have to return the indexes for it. So 9 is at index 0, 1, 2, so this would be 2 here. Let me just not write it once, and this would be 3. Now the thing is that our solution actually requires us to increment it by +1, so we cannot actually return indexes in starting from 0. So we have to consider this place as 1, this place as 2, this place as 3, 4, 5, 6. So we'll have to do a 3 here, just add 1 to it, and we'll have to do a 4 here, and this would be our answer to it. So let's just make 2 pointers first. So I'm going to make a pointer, and let's just name it pointer A, and a pointer B, and this pointer B would be numbers dot length, since it is starting from the end index. Then we'll create a while loop, and we actually have to end the loop once this pointer A greater than or is equals to pointer B. So we can pretty much say that if pointer A is less than pointer B, then keep the loop going, otherwise don't. Now let's sum up the values at these pointers. So I'm going to write a variable, let's sum is equals to numbers A and numbers B, and let's write a if condition to check if sum is equal to target, then we just return. Else if sum is greater than target, then we are going to go back a bit. So you might remember from our example here that when sum was actually greater than target, then we had to decrement the pointer B. So let's decrement the pointer B here, which is PB. So we're gonna decrement PB, and let's just write a bit more clearly like this. So we're gonna decrement PB, and I can actually do the else here, or I'll actually make it more clear by doing this instead. So I'm going to say if sum is actually greater than is less than the target. So if the sum is less than the target, then we have to increment our pointer A. So let's increment our pointer A here. Am I doing it correctly? I don't think this is the way to do. This is wrong as well. Let's just fix it. Okay. So we have incremented our pointer A as well, and we have decremented our pointer B, and that's all actually. But we actually have to do a little bit a change here, and that's because we cannot have our indexes starting from 0. So our indexes are incremented by 1. So when we are returning PA, we just need to do a small change, which is like just increment both of these by 1, and then we can actually run our code and see the results to it. And this is actually passing all the test cases, and let's just submit this to the LeetCode to see the performance of it. And there you go, guys. So it is giving 74.54% of performance, and this is an accepted solution. So our solution to this is time complexity is O of n, and space complexity is O of constant, because we are not using arrays or anything else here. So that's all, guys. Hopefully you guys understood this, and if you did, make sure to leave a like and subscribe. That helps the channel a lot, and I'll see you guys next time with another LeetCode challenge or something else. So take care, bye bye, and I'll see you guys later.